Hello my precious friends, I really hope that you are doing great. Welcome to today's class. It's our 8th lesson on a given Form 3 mathematics topic called Approximations and Errors. So we are looking at our 8th example, which reads that the height of a rectangular tank is exactly 5 meters. If the dimensions of its base are given as 2.5 meters by 1.8 meters, calculate the percentage error in the volume of the tank. So we'll start by getting the absolute error, the absolute error in both the length, and width of this particular rectangular tank. So absolute error, of course, will be a half of. So of course, this is our length, then this will be the width. So our length is correct to 1 decimal point. The width is also correct to 1 decimal point. So our absolute error will be a half of what? 0.1. Remember, if our length was 2.55, then the absolute error, in that case, we will take a half of what? 0.01. If also, let's say our width was something like 1.800, then the absolute error in that case will be given by a half of 0.001. Also, if the length was, let's say 2.0, then it means that the absolute error in that case will still be a half of what? A half of 0.1. So the absolute error depends with the number of decimal points in that particular case. So since both the length and the width are correct to 1 decimal point, so this is 0.1, this is also 0.1, absolute error will be a half of 0.1, of course, which is gonna give us 0.05. From there, we are going to get the range or the limits within which our length and also the width exists. So the actual length was 2.5 meters. So the maximum possible length, I'll take 2.5 plus 0.05, which is the absolute error. So 2.5 plus 0.05, I'm going to get 2.55 as the maximum possible length. Then to get the minimum possible length, I'll take 2.5 minus the absolute error in the length. So 2.5 minus 0.05, of course, I'm going to get 2.45 as the minimum possible length. I'll do the same for the width. So the exact width was 1.8 meters. So to get the maximum possible width, I'll take 1.8 plus 0.05. So this will give me 1.85 as the maximum possible width. Then to get the minimum possible width, I'll take 1.8, then minus 0.05. Of course, this will give me 1.75 meters. So these are the limits within which our length and the width exists. Remember, we are told that the height is an exact value. Exact values do not have absolute errors. So because they want us to get the percentage error, we shall need the absolute error in the volume. Therefore, for me to achieve that, I need to have the maximum possible volume and also the minimum possible volume. So Vmax, the maximum possible volume, will be given by, so of course these are rectangular tank. The volume is length times width times height. So the maximum possible volume, I'll take the maximum possible length multiplied by the maximum possible width, then of course multiplied by the exact height. Remember, when a certain dimension is exact, it does not have the maximum value and the minimum value. Instead, the value itself becomes the maximum, the minimum, and also the exact or the actual value. So this will be given by the maximum possible length was 2.55. So I'll have 2.55, then multiplied by the maximum possible width, which is 1.85, then of course multiplied by the exact height. The exact height was 5 meters. So if I take 2.55 multiplied by 1.85 times 5, I'm going to get the maximum possible volume of 23.5875 cubic meter as my maximum possible volume. Then I also need the minimum possible volume. To get the minimum possible volume, I'll need the minimum possible length multiplied by the minimum possible width, then of course multiplied by the exact height. So the exact height. So this will be given by the minimum possible length, of course, was 2.45. So this value here, 2.45, multiplied by the minimum possible width was 1.75. So times 1.75, then multiplied by the exact height was just 5 meters. So multiplied by 5. So of course, you compute this on the calculator, the minimum volume will give you 21.4375, 21.4375 as the minimum possible volume. Now, having the maximum and the minimum values, that is the volumes, I can get what we call the absolute error in the volume. Therefore, the absolute error in the volume, will be given by absolute error in the volume. It will be given by a half into V max, the maximum possible volume, minus V minimum. So this should give me the absolute error in the volume. So this will be a half into my maximum possible volume was 23.5875. Yeah, it is here, 23.5875. Then minus the minimum possible volume is here, 21.43437.5. So this, the difference between the two will give me a half into 21.5875 minus 21.4375. The difference will give me 2.15. So of course a half of 2.15, this will give me 1.075. So this is the absolute error in the volume. Of course it is in a cubic meter. Now, having the absolute error in the volume, to get the percentage error, we need the absolute error in the volume and also, of course, the exact volume. Therefore, I'll compute exact volume, V exact, or the actual volume. The actual volume will be given by the actual length multiplied by the actual width, then of course multiplied by the exact height, So this will give me the actual length was 2.5 meters. So I'll have 2.5 meters multiplied by the actual width was 1.8 meters. So times 1.8 meters. Then the exact height, of course, was 5 meters. So this will be equivalent to 2.5 times 1.8 times 5. I'm gonna get 22.5 cubic meter. So that is my actual volume. Now, if I want to get the percentage error in the volume, this should be the formula. So percentage error in the volume will be given by percentage error in the volume of the rectangular tank will be given by absolute error in the volume, the absolute error in the volume, divided by the actual volume then multiplied by 100%. So this will be equivalent to absolute error in the volume was 1.075. So this is giving me 1.075. Of course, it is in cubic meter, divided by the actual volume, which of course is 22.5 cubic meter, then multiplied by 100%. So this of course is going to give me 1.075 divided by 22.5 times 100. This will give me 4 whole number 7/9. 4 whole number 7/9%. So this is the percentage error in the volume of the tank. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you're new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.